Hello dear, how are you today? I hope to see you soon. Today we will solve exercise 14, 15, 16, page 99. Let's start by exercise 14. Let's read it together first. Are the two numbers 2 to the power 6 and 6 power 2 relatively prime? Justify your answer. Two numbers are relatively prime if the GCD is 1. It means that there's no common divisors between them except 1, of course. So, what do we know about 6? 6 is not a prime number. Can we write it in the form of prime number? 6 squared can be written as 6 is 2 times 3, all squared. So this exponent goes to every factor inside the parentheses. It can be written as 2 squared times 3 squared. Okay, here we deal with 2 power 6 and 2 power 2 times 3 power 2. Is there a common divisor between them? I see that factor 2 is repeated at both of them. And while finding the GCD, I take the common factor with a smaller power. 2 is less than 6, so the GCD of 2 power 6 and 6 power 2 is 2 to the power 2, which is 4. 4 is different from 1. And since the GCD is different from 1, so the numbers are not relatively prime numbers. Okay? If you understand well the concept, it's so easy. Two numbers are relatively prime if their GCD equals to 1. Okay? Since we find the GCD, which is different from 1, so they are not relatively prime. Now exercise 15. The question is, are the two numbers 3 power 5 and 5 power 3 relatively prime? Look, did you notice that 3 and 5 are both prime numbers? So they are divisible, both of them, by 1 and themselves. Okay, so the only common divisor between them is 1, right? And since their GCD is 1, so yes, I can say that 3 power 5 and 5 power 3 are relatively prime numbers. Okay? Now exercise 16. Prove that two numbers 375 and 392 are relatively prime. Look, they asked me to prove. They told me that they are relatively prime and I have to prove it. That means I can't say no, they are not relatively prime. They are relatively prime and I have to prove it. Let's take a look at the numbers. Here we have 375. Definitely it's not a prime number. It ends with 5, so it's divisible by 5. 392, it's an even number, so it can be divisible by 2, right? What should we do here? We have to write their prime factorization. 375. We can say that it's divisible by 5, and we can say that the sum of its digits 3 plus 7 is 10, 10 plus 5 is 15, 15 is a multiple of 3, so 375 is divisible by 3, its answer is 125. Now 125 is divisible by 5, the answer is 25. 25 divided by 5 is 5, and 5 divided by 5 is 1. So I can write 375 is 3 times 5 to the power 3. Okay, it's 5 times 5 times 5, so it's 5 to the power 3. Now let's write the prime factorization of 392. What should we write here? It's an even number, so it's divisible by 2. 392 divided by 2 gives me 196. It's also an even number, so let's divide it by 2. The answer is 98. 98 divided by 2 is 49. 49 divided by 7 is 7. 7 divided by 7 is 1. So 392 is 2 to the power 3 times 7 to the power 2. Okay? It's so easy here. We all know how to write the prime factorization, don't we? Now, we have to prove that they are relatively prime. And the rule says numbers are relatively prime if their GCD is equals to 1. Let's see here. On one side I have 3 times 5 cubed. On the other side I have 2 cubed times 7 squared. There is no common factor between them. 3 and 5, and here we have 2 and 7. So their GCD is equals to 1. Then we can say that 375 and 392 are relatively prime numbers. Okay, dear? You have to write the solution of this exercise on your classwork copybook. Please contact me if you have any questions. Thanks for your attention. Bye bye.